Good evening and welcome to the Fire Sprinkler CAD Basics Bootcamp. This is week 6, an introduction to hydraulic calculations. I'm your host, Colby Stachwick, and last week we went through our preliminary drawings and we verified that we had all of the information that we needed on our drawing so that this week we can complete our hydraulic calculations. And there's a lot to go over. So let's go ahead and get started with our presentation. Let's see. Let me shift things around here. That's better. Okay. So again, welcome everybody tonight. Again, this is week 6, an introduction to hydraulic calculations. Hopefully you've had the opportunity to review the last 5 weeks information. With me tonight is my lovely wife, Monica, in the background here, helping me as well. We have Chris Carrasco is helping remotely from Southern Oregon, and Martin Carl is helping remotely from across the pond in England, helping us with recording. So we got a little bit of a team going on here tonight. I want to thank everybody for helping out. And just to make sure everybody is where they are supposed to be, this is the CAD Basics Fire Sprinkler CAD Basics Bootcamp. We are on week 6 of 8 weeks. Well, that's so what? About 3/4 of the way through it. We will be through it tonight. So really, this is, some of the more heavy information. A lot of this can feel overwhelming. At any time, it feels like you're taking this information through a fire hose. This picture reminds you of how you feel. We have plenty of opportunities to try and help you feel successful. Up until this point, have you completed your pre-calc checklist? If you don't want to be behind, that's where you should be. And if you haven't, we're going to mention some opportunities that you have to be able to come and get some help to be successful and to get caught up so that you can complete your NFPA 13D fire sprinkler system design. One of the ways is in our community where you can go and get help from other members that are doing the same thing as you. And one of the things that's in the community as well is that Saturday there is a live video feed that is different from the one that you are at now. This is Zoom, but the mCAD community on Kajabi, we have a workshop on Saturdays with Chris Jansen, and this Saturday, he's going to be starting a custom desk design. He's been playing around with kind of some basic making of, basic building elements, 2x4s, plywood, those types of things, and manipulating them, moving them around. And so now he's going to start using those skills, putting them together to start designing and building a desk. So he's got in mind a workstation for doing CAD work. And that's what he is going to be working on. So if you want to check that out, come this Saturday. And also there will be an opportunity afterwards for questions regarding that, as well as anything else related to the course that we are doing. And so if you sign into Kajabi and go to the library, scroll down into this area where you see this community tab, click on that view button. That's how you get into that stuff that I was just talking about with Chris Jansen. There's also like forums, places you can post questions, post your work, ask for input from your peers. If you go to the library and scroll down, also we have, this is where you go to access your boot camp, the main lessons for the course. Besides this live lecture, this is what it looks like to log on to your course. And this is where all the detailed, specific information is to help you through to produce your 13D project. So we are at right now to this iteration of the bootcamp. We are doing it on Thursday nights, and we are here on Zoom. And immediately following this lecture, we will be doing a live Q&A. So if you have questions tonight, bring them here. And anytime after a lecture on Zoom, we will be doing the same thing. So if you have questions, make sure to come and get them answered. So also, when we are doing the live iterations of the bootcamp, we make myself available if you go to the library and then under consultants, Chris Crosco and Chris Jansen are also here available for payment, but just during the boot camp, I am here for free. So if you need help, you can sign up and get me one-on-one with you to walk you through whatever you need to get to be successful. So one thing I want to iterate again, always, every week, we can't say this enough. I have a standing desk. I have a standing desk here with my computer, another one over here for looking at plans. You know, sitting all day, one position, operating a mouse, these types of things, it's really hard on you actually. And I cannot say enough, you need to get a scroll wheel mouse if you don't have one. It's really necessary for zooming in and out with these 2D CAD programs. Will make things much easier. And I want to mention again that I haven't brought this up for a few weeks, but as you'll see with the hydraulic calculations, like it's really a lot to have going on, especially if you're on a laptop, you know, it's just one little screen. So it can really help to be looking at calculations and your drawing to have two screens going. But right here is my calc program and my CAD program. So you can see that it can take up a lot of real estate fast, especially if you want to see anything. But what you can do if you only have one screen and you're on a Windows machine, if you hold down the Windows button, you can hold down or press either the left or right button to divide your screen up like that evenly. And on a Mac, on this green button here where you go to enter full screen, you also have the option to tile to left or right. So you can get the same effect if you are on one screen. So we have been working through this process, right? We started back in week 2 with the layout checklist, and we talked about the red lines. We have some back and forth. We completed last week, now the pre-calc checklist. And so here's our layout checklist that we went over. We also got at the very beginning a job order report. This gave us some critical information that we needed to complete some tasks. And this is an example of a file folder. You're just kind of working through some iterations of the project. Remember, each day that you work on it, you start the preliminary that day, start with A, work through the alphabet for that day. When you start a new day, start over at A. But that way we just have a record working through how we worked on the drawing. And we don't accidentally overwrite things that we might need. So, this is where we ended up after we went through the layout process, the layout checklist. Then we got to the pre-calc checklist. And we added our heads and our piping. And the whole insinuation here, pre-calc, and then next week we're going to be doing a post-calc checklist. Well, there must be something called hydraulic calculations in between. And so that's what we're going to be talking about. And also, in addition to hydraulic calculations, we're going to talk a little bit about water supplies, different options for 13D, because you kind of need to talk about both of these things together in these systems. And, this kind of gives you a basic introduction into water supplies for, 13 and 13R systems, just to it's just a little bit easier break to start with this stuff. So we're talking about in NFPA 13D, and now in Oregon, I'm in the 2019 at this moment, so that's why I'm quoting the numbers out of that specifically. Where you're at may vary. I know we've got some people in California in live right now, and they're in the 2022 version. But in 2019, 10.4.3, it says that pipes still be sized using one of the following techniques. And so there's 4 of them. We're going to be going through some of them. I'm going to try and go faster than I am. I know I tend to give too much details. We got a lot of slides tonight, but there's a simplified calculation method of 10.4.4, and there's some stuff, but it's basically, what is the word? It's going to come to me, but instead of using a calc program, there's some charts in the book, and prescriptive, that's the word. It's a prescriptive method. It's aimed to simplify the process because the whole point of 13D is to bring the cost down for homeowners. And so they don't want to require homeowners to have to buy a expensive calc program if somehow they're going to design their own sprinkler system, or just to keep the cost down for the sprinkler contractors, I guess, that are doing it for them. But not a lot of people use this prescriptive method, but it can only be used if the system is directly connected to a city main of 4-inch size or larger. And I've tried using it a long time ago when it first came out, and it got rejected because they hadn't seen this yet. But it's more common now, and you can submit these and get a permit. There's another prescriptive piping method of 10.4.9. I think I'm getting in the weeds too early. I'm just going to go over these briefly. We'll talk about what the difference is between the two prescriptive methods. Then we're going to go into 3 is the hydraulic calculation procedure per NFPA 13, and that's the style that we mainly do and we'll be focusing on. The other option is the manufacturer's listed installation instructions, and this is basically the only one out there that I can think of that's doing this. There's probably more, but the only one that comes to mind is Upnor or Upnor, however you say it, Wurzbo. If you get a PEX system from them, you have to have them design it. And we'll show you what that looks like. It's a little bit different. But no matter what, when we're talking about hydraulic calculations, the important information always related to this is water supply. How are we going to get water for the sprinkler heads? We need water of some source. So different available water supply sources that we're allowed to use in NFPA 13D 6.2. One of them is a connection to a reliable waterworks systems with or without an automatically operated pump. So connection to city main, basically just your regular water line connection to a city main in the street. That's what that's talking about. And when we do a test in a city main to see what kind of pressure we have to work with for doing hydraulic calculations. Now, mind you, NFPA 13 style hydraulic calculations, we're always going to do this type of test with a static residual and getting a flow. NFPA 13D does allow for calculations without a residual pressure on a 4-inch main. But when we're doing a 13 style calc, this is generally what we're looking for. And so we're going to be doing a flow test. I've got some show and tell stuff. We got this little device here. It's a pressure gauge. And you'll notice at the top of the picture there, I hope it's probably kind of small, but there's a yellow thing up there that's a hydrant. And so that would have this gauge on there. And you open up that hydrant so that there's pressure against this, and you get a reading off it, and that would be your static pressure. Static means the pressure that the water has without any movement. And so then we go down to this next hydrant at the bottom of the screen there. We open that one up wide open. While that's wide open, we check the reading on this same gauge that we left back on that other hydrant, and that's our residual pressure, or the pressure when water is flowing. So when the hydrant's opened, this number is going to drop. How much it drops is what we're really concerned about. Then we have various types of gauges called pedometers pictured in this image I have on here. It's a really nice pedo gauge with a diverter so you don't make a mess. I do not have the privilege of owning one of these fancy ones, but I still have one of my old school pedos here. And I wouldn't even probably use this. Probably it's been so long, it probably needs, I know my gauge over here is no good. That needs to be replaced. This one might be okay, but it's pretty old, needs to be updated. Basically, when that hydrant is flowing full bore, you stick this right into the center of it. There's a little tiny hole at the tip that you'll never see. That you have to hold it while you're getting sprayed down with water. and you get a reading off of that, and that gives you your flow in GPM. And we're going to be talking about, like, basically every place that you do a sprinkler job, it's different how you gather this information. Let me go back to this picture while I'm explaining this. Um, some places you get the job and you go do the flow test and you just go do it. It's no big deal. Some places you have to schedule it with the local authority, and it's always different everywhere who handles this kind of stuff. I mean, it's usually somebody related to the water department, but sometimes in some areas it could be the fire department that keeps the records of these different flows and whatnot. It just varies so much all over. It's like when we first get a sprinkler job, one of the first big things we're worried about is, okay, where is this and what do we got to do to get hydrant flow at this area? Because some areas, like if we could just always go do it with, that'd be no problem. It's no big deal to do. We'll just go do it. And a lot of times they will have rules. It's like, no, you guys can't do it here. You have to schedule it and, go through this system. And may work, may not. Here it may be, free and they get it done rather efficiently and, no big deal. Okay, but we have to wait on them. We can't do it. Another place, it may be $500 and we have to wait a minimum of 2 weeks on them, and there's just nothing we can do about it. And then we might not even get it in 2 weeks. And at that point, it's just all over the place on what it is to get this water flow. And it's always like, it can be difficult at some places and beautifully easy at other places. And we're going to be showing you how the city of Portland does it, because there's certain things about their system that make it nice because it's easy to get the information that you need. And so we can demonstrate all of the information for the purpose of this course of what we're looking for. But the process of gathering all this information can be radically different from town to town, even in my state, jurisdiction to jurisdiction, county to county, just wildly different. But so City of Portland has an interesting thing. They have where you just email them. They have people at the Water Bureau who are dedicated to this. They have a special form that you fill out where you need the water flow information for, and you send it in, and they give you this form back in pretty quick. It's usually like the next day. It's really pretty amazing. But all of this is oh, nice. I see in the comments somebody mentioned that in Southern California, $525 in 2 to 4 weeks to get a flow test. See, it varies all over. It's crazy. Okay, so this Portland one, it's free. That's one nice thing. But one thing that's kind of wild about it is it's a simulation. It's not a real flow test. They don't do flow tests in the city of Portland. And let's see, yes, the reason I have this is my next slide. I wasn't sure if this was the next one or not. The reason they don't do flow tests in Portland is because they're too afraid. Like basically, they haven't flowed any like you're supposed to flow hydrants regularly, like flush them because sediment builds up at the bottom. But they have these wooden water mains, like scattered throughout the city in various places that they're still finding in places and removing. Like this was just, I found this 6 months ago. I think it was in the Willamette week, if I remember right. And I think this is just from a project. I want to say it was in 2022, if I remember right. So like they're really all the time still finding this stuff. It's kind of crazy, but that's why they don't do flow tests and hydrants, because they're afraid of it'll just blow this stuff apart and cause havoc. So they do this simulation, which it seems to work pretty good. So kudos to them, I guess. But so we're going to take a look at this breakdown of the simulation. We sent them an address and they gave us some information here. It's an 8-inch main. This isn't so much important for 13D, but for 13 projects, they especially want to know what size is the main in the street. if we're doing that calculation method where you talked about where it can only be done if it's a 4-inch main, you would want to see this. But City of Portland here, one of the things I'll mention too, when you submit plans to Portland, you are required to include this computer simulated water flow as documentation with your plan submittal and calculations. Anyway, let's keep going through this. So we've got 8-inch main. Now, an interesting thing that Portland also has to kind of go along with this that's really handy that not everybody has. It varies greatly how much of this information you'll get. But they have this website called Portland Maps, and you can just go and look up these addresses, and it'll show you the city main and in the street. This is our address. And we zoom out a little bit on it. We can see how the main is connected to the greater main system. If we go into what I'm trying to show you now is like we are just kind of like gathering information. This is an existing house. I don't want to drive there. We could, but we have modern technology. We have all the stuff that you're seeing. We're painting a picture of what this water system looks like. I went to Google Earth and there's a water meter. So this is the house. The water is entering right there. And if you turn 90 degrees on Google Earth, there's a hydrant right there. Well, that hydrant is this dot on this map. So these are the kind of tools that we have to kind of map out where things are. Some places don't have as nice of a map like this with underground. Some people, like some jurisdictions over here, when you apply or send in a request for the water flow, they will basically send you back a report with all of this stuff that I kind of showed you that Portland has for you to look up. They just send it all to you, which is nice also. And, other ones just kind of give you bare minimum or say, no, we don't have it. Go figure it out. I mean, it's a wide range. So back to our report. Let's see what else. What other information can we glean from this? If we zoom in a little bit, the important stuff that we're looking at is our static pressure that we use for our design. You'll notice that they make us use 80% of the pressure because it's a simulation and they don't trust it. One of the interesting things about City of Portland as well is that you also have to put a forward flow connection on the riser so that you can test it after the fact to make sure that there is enough water, because we are going off a simulation. Not really sure what happens if there isn't at that point, who's responsible, but because that box that I kind of chopped off, that note on there, it's them a big disclaimer saying it's not our problem if it doesn't work out. But anyway, so you use this 47% or 80% of the total. They say there's 59 static, but you got to go with 47. And the estimated flow is 1,300 gallons per minute, and estimated residual is 20 psi. Oops, I guess I had arrows to point at that so you guys can see what I'm talking about. But there's 1,300 GPM and 20 psi residual. These are the three numbers that are important for our calc. And here's there's a cool website you guys could check out, pingfire.com. You can graph flow tests for free. You can print out a report, and contractors out there that are doing flow tests, you just put in your job information if you want to, and then the hydrant test results that you get, and it'll graph it. And so that's our flow curve. And so when we're designing a sprinkler system, you're going to see this graph, a similar graph to this on our hydraulic calc program. This line, which they call a flow curve, which is actually a straight line, but it represents the available water supply. And so as long as the demand of our design always ends up underneath this curve, we will be good. We also have to have a 10% pressure cushion, but The general idea is we need to stay below that line. So some things to consider on our 13D systems that affect the water supply you need to take into consideration is like the water meter. If it is coming through a water meter, there will be a double check valve. Like this picture, I have a Watts 007. Those are really common in our area to separate the domestic plumbing from the sprinkler system, because the sprinkler system water will stagnate and you don't want it to mix with the plumbing water. I think we kind of had some conversation in the Q&A a couple weeks ago. There are alternatives where you don't have to have the double check valve, called a flow through system, where you tie them into toilets so you always get water continually flowing through it. It can be a good idea because double check valves do require maintenance. Other things to think about, if there's any valves that you have between the main and your sprinkler system, you got to add that into your calc. It's the pressure loss that's going to have an effect. Water softeners, like we have in the picture, you basically cannot have those before your sprinkler system. They have to be after on your domestic system. This is a diagram out of 13D showing how to break apart the water main as it comes in to separate the sprinkler system and the domestic. It's kind of, I don't know. This is a flat representation. The lower part there that shows to the sprinkler system with the water flow detector and pressure gauge is represented on our drawing by this. This is the riser detail. That valve in the middle there is that Watt 007. Just kind of showing that picture there so you can get an idea of what we're looking at. This is just a valve in the wall to keep the water from mixing from the sprinkler system with the domestic, and then we have a drain on the side. So let's see okay, besides connection to a city main, another common thing we have for houses would be a well, or also we have cisterns a lot here in Central Oregon, which is basically a well with a concrete pump next to it. I mean, a concrete tank. Okay, so water supply sources, number 5 in NFPA 13D 6.2, it says a well with a pump of sufficient capacity and pressure to meet the sprinkler system demand. So when we look at that, basically it's exactly the same as the last setup, but we just replace the city main with the well or cistern, and there's not going to be a water meter, obviously, on your on your well. Actually, I shouldn't say obviously, because I know that there are actually places that are moving to meter well water, crazy enough. But we won't get into that now. But you would have the exact same riser setup if you're on a well or on this city main. You'd have the same thing, and you have to consider all these other things as well. It's just that we, likely wouldn't have the water meter is all. Now, this is a typical well pump, just kind of showing what those look like. This is a cistern here in Central Oregon. If a place has a weak well, they will have 2 of those well pumps that I just showed, one deep down in the well, and then one also at the bottom of the cistern, which is just like 10 feet deep or whatever. I think they're usually like 10,000 pounds or gallons, and shared between like 3 places. And they work really well, quite frankly. It's a good system. The wells are weak, but they refill overnight. Those pumps just run and run and run. They're workhorses. They're designed to be that way. And having the pump in there where it doesn't have to draw the water, it's the same type of pump, but it's designed to run forever. It doesn't have to draw the water up out of the ground. It just it's in just this big pit. So it has an easy time pumping the water, and so you have great pressure. On the left here, it's talking about feet of depth down, you know, so if they're designed to work at up to 900 feet down, some of these, you know, they don't even use those huge ones when they put them in the cistern. I think they usually use like a 2-horse, but that's designed to work at almost this looks like 375 feet down. And so when we put it at, you know, 0 head pressure is what that would equate to, where it doesn't have to suck up from underneath the ground, the water. It just works tremendously well. All right, so other options, we have stored water supply with a pump. This is what we're using in for our project. This is particularly what I'm showing here is Talco Pump out of Clackamas, Oregon, makes this home hydrant, which is really, I mean, they've done a nice job with this. I really have a lot of respect for this company. I kind of watched them come up. Toured when I was more in the field, toured their facility probably 15 years ago now. And they're continually improving their product, and it's really it's a pretty solid product now, and because of that, they're selling this all the way I know in Portland, Maine, because I have a client that's here in Oregon that has actually been able to find them cheaper by purchasing them and shipping them from Portland, Maine than buying them locally. I'm not sure how that works out, but they are a good product. And it's just all in one. The pump sits inside it. It's designed to fit within a closet, a standard closet, so that can be convenient. Now we are working with 4.9 K factor Senju head, and you'll notice on here we got 12 by 12 spacing, 14 by 14, and 16 by 16 spacing. They all are at 13 GPM. And so this head really works the most efficiently at 13 GPM. And I'm trying to remember. Okay, yeah, that's just thinking about this is when you just thinking about sometimes you have limited water supply. And so there's ways that you can play around with your sprinkler heads. If we go to a 3.0 sprinkler, we can reduce our water demand down to 9 GPM for a 12 by 12 spacing. And so we know we need a 10-minute supply for 13D. And so if we now only need 9 GPM out of 2 heads, that's 18 gallons a minute for 10 minutes. That's 180 gallons. So you only need a 180 gallon tank now. Whereas the one we're using in our project, that's 13 gallons a minute. So that's 26 gallons a minute for 10 minutes. So 260 gallons. And our tank happens to be 350 gallons. So it's extra capacity. Anyway, but just trying to show you that there's things that we can play around with here when we have, sometimes you can use this option to make an old water supply, existing water supply work. If you're trying to do that, save the money in the tank and pump. There's just different options we can play around with. And I just throw this in here because when I was getting some of this info off of the Senju cut sheets, they had this nice detail that I thought I'd share with you for you guys that are not really familiar with sprinklers and their operation. I have a similar sprinkler here. It is not a Senju. It's an old central sprinkler, actually. But basically, there's a flat cover plate that is below this. And what you're seeing in the picture here is the first thing that happens is that cover plate falls away. And then this part in the center drops down, the deflector. And then after the deflector drops down, there is the first cover plate has solder holding it on, and the solder melts about 20 degrees before the head will go off. So it drops down in preparation. And then when it gets hot enough, the little bulb inside of there, or solder, depending on the design of your sprinkler. The Senju sprinklers we're using for our class project are solder. So when that solder melts, the water comes out like we see in the illustration here. And the deflector is what makes it come out and spray in a circular pattern and spray out and spread onto the walls. You can see the arc of the circle up near the ceiling about, I think, you can look in some of the cut sheets for the sprinkler heads. They have graphs of this. I don't think Senju does, but I know Reliable seems like they always had a nice one on there that shows it. Really helps to visualize that. Maybe I should add that to our slides here. But let's keep going here. We're talking about calculation options. Okay, now we're going to get into the meat of what these calculations options are that we mentioned earlier. Now that we understand what our water supply options are, we understand what the limitations of what maybe our water supply is that we're dealing with. Maybe we can get a tank and pump to solve it, but how are we going to calculate? Well, the simplified calculation method of 10.4.4, again, only when it's connected to a city main, 4 inches or larger. This is a prescriptive method, and there are tables in the code book, and there's nothing against it. I've seen guys get permits with it, and it's no big deal. Use it. You don't have to have a calc program. You basically just end up, adding up your fittings, adding your lengths of pipe, and going to tables and, getting equivalents for pressures that you add up in these tables. Now, there is another prescriptive method, and it's the 10.4.9 method, and we really don't recommend anybody use it, but I just want to read this little blurb that is written in the 2016 13D handbook that I had. It says it's a historical note. It says the simplified technique was developed to mirror provisions. So that it's talking about the simplified technique that we talked about on the last slide, the one that is okay to use, to mirror provisions added to the International Residential Code that were helpful, or the IRC, that were helpful in getting mandatory requirements for single-family homes to be sprinklered under that code. This method was also submitted to NFPA 13D for consideration. The committee determined that the technique was consistent with the philosophy of NFPA 13D and included the tables in the standard so that there would be no question that the technique was acceptable. So basically, the IRC is a code path for building homes. They really were pushing NFPA 13 to create a prescriptive method because the IRC is prescriptive, because it's all about letting people do things prescriptively. And NFPA 13 developed one, but they weren't doing it fast enough. So IRC put theirs out first. Well, it's kind of awful, so don't use it. But it's just a historical thing that's there. You could use it. It's legal, but you'd be hurting yourself. You're just going to end up with potentially bigger pipe than you need to use for no good reason. But so that's we don't need to say any more about it. This is like a worksheet for working through that. It's just a prescriptive method. You just add up your fittings, your length of pipe, those types of things. So don't do this. If you want to do a prescriptive, use the number 1 NFPA 13D method, not the IRC method. So let's see, what else do we have here? Before we get to number 3, because that's the main one we're using for our course, we're going to skip ahead to number 4, which is the manufactured listed installation instructions. And that was one I was talking about earlier with the Wurzbo. Here is a example of a PEX system designed by Upnor. And if you get a system designed by them, they will send you these plans, and you have to order the whole shebang from them, get your piping, sprinklers, everything, fittings, hangers. But this is their plans, and they have all this warnings on here that only people who have been trained to go through their system can install these plans, and no one can alter these plans except for people at Upnor. But this is basically what all it is that they have an in-house design and put their name on it. It's really no different, but this is what's considered a pre-manufactured design, because Upnor is a manufacturer. but they're just doing all this stuff in-house, the same things that we would be doing. So the main thing now we're going to go into is the NFPA 13 style calculation procedure. And one of the reasons why I like to teach this with 13D, because 13D calcs are simple, and it's a great way to introduce you to more complex calcs later for 13R and 13. So we do have a video of inputting the information from our project that we're working on, the sample ranch home, into Sygma 8800 hydraulics. And they're actually, we need to update. They're at 8850 now. But, that's, if you want to see how that calc program works, it's 50 minutes, it looks like. But for a lot of you, that's not really, might be kind of boring. If you're not going to use Sygma, it might not be relevant. We're working on adding other calc programs. We have a couple other in our, what would you call it, in our tool belt here. We just haven't had time to produce videos with them yet. So we will be adding those as we do. But since we don't, instead of going through how to do the calculations in a calc program, what we're going to do instead is we're going to talk about how to read the calculation reports. And there will be, I didn't have a thumbnail yet because it's going to be made from the recording of these slides that we're about to go into. But if you go into your course for this week, this lesson, number 4, it will be the next lesson after that, number 5. And it's reading hydraulic calculation reports. And so in there, you will find this PDF, this report that we're going to be talking about. We're going to be going over how to read this report. And you should also find this hydraulic calculation checklist. And this is a new thing that we have developed actually since the last iteration of the course. We didn't have this checklist, but this has been helping us tremendously to scale up our business to be able to, before I was the only one that was doing and checking hydraulic calculations, and there was a lot of room for error. And now we have a process and many people doing calcs, and I and other people who can check them, and a systematic way to go through them. So we are going to still clearing out my whatever cold I had last week. I got a little bit of a cough that's lingering, but so you'll have to pardon me. But we want to read this note on the top of the page here, the technician's note. It says using a hydraulic checklist is critical for ensuring your NFPA 13D hydraulic calculations are accurate and complete. It provides a systematic approach to review key elements, catch potential errors, and confirm code compliance, helping to avoid costly mistakes and ensuring dependable system performance. So, we're going to take a look at the very first one we have on here. Now, this is for our company, so, not everyone who's going to be checking over calcs is going to be caring about the contractor logo. But one thing that we like about Sygma is if you can just leave the Sygma logo here on the cover page of their calc report, but you can also modify it and put in whatever logo you want. And so we really like this option, and we'll always put in the logo of the client. And it just, it's a nice professional option. All right, so we went through the contractor logos. Now we're looking at verify project information. So the project information is this box on the upper left hand. And I'll want to note that this report is where everything is laid out, pretty much what's on here is per NFPA 13. And so all of these reports are going to be fairly similar. You should be able to find the information that we're going to be talking about, other than the logo is not universal. It's just something we like. Um, but so all of this stuff should be universal to like cover pages that we'll be talking about, no matter what calc program you're talking about. So we're going to have always going to have project information. And, you know, in this case, we're working on our sample ranch home for the class project. It doesn't, as I looking at that, it doesn't quite match our address on our drawing. And that's really what we would be looking for. What's most important is just that we have continuity with our calculations and our drawings. And so next thing on our list is verify contractor information. And so that's just right below on our cover page. And I just have mCAD thrown in here. But if you are working with a client who's a contractor, or if you are a contractor, you will have that information in there, their contact information, phone number, email, whatnot. And again, this should match the information that you have on the drawing for the contractor information. Okay, so now verify sprinklers in remote area. We're talking about this portion of the cover page that's describing the remote area. And so we've got two Senju sprinklers, 4.9 K factor sprinklers in our remote area. If you guys remember from it was last week when we finished our pre-calc checklist, we put our nodes in our kitchen, and those are the two sprinklers that we calced, that node 11 and node 12. And if you guys are curious about the process, again, in that video I mentioned, we show going and entering all of the information between the nodes in Sygma, how that works. But so on our node legend, we have the 4.9K sprinkler, and we just have that generically on there. We generally, when we send out jobs, we try to put the specific model number of the sprinkler there. And it's not always 4.9, but that's the most common one we use for residential. All right, so next thing we have on our list is verify hydraulic criteria. And so that's this box here. Let's see, I did not. I thought I might have made a zoomed in one. So that's okay. The reason I didn't make a zoomed in one is because we're just talking about the box. We're going to talk about what's in the box individually on other slides. So that's these 4 items: design density, area of application or remote area, hazard classification, and system type. And so in that hydraulics criteria box, right here is where we have the density, and this project is a 0.05 for our 13D system. Next thing we have is area of application. That would be the remote area, which is 2 sprinklers. The sprinklers are covering 256 square feet, so 2 of those would be 512 square feet. Next, we have our hazard classification, and this is the residential project, so it's just residential. This is more applicable because this is a 13 style report. In NFPA 13 calculations, we have like things called light hazard, ordinary hazard, extra hazard. But for this 13D and 13R, it's just residential. All right, so then system type. What is that? Well, system type is wet. There are also dry systems that we work with, which just means that there is no water in the pipe until the sprinkler system is activated. Then it is filled with water. These are used in areas basically subject to freezing. Some of you may not be too familiar with because don't have a lot of freezing where you're at, maybe. All right, so now that we have the 4 of these items checked off, we can check off number 5 because those 4 items, 6 through 9, are basically all of what's inside that hydraulic criteria box. So now the next thing we're going to look at is basically our flow test information, our static residual pressure and flow, where it goes on the calc report. Now, this is the box, and I normally on a tank and pump do not put this information. I kind of talk about in the video on creating this calc report that some jurisdictions like to see that that demand curve we were talking about for the flow test, but there isn't one for these little pumps. And so putting these numbers in there, what we explained in the calc thing, is like a way that some people fake it in basically to make it create a curve, but it's really not quite right. And I don't do it that way, but I'm just showing you how you could if you wanted to. Basically, our tank and pump will do 30 GPM at 50 PSI, but there is no static pressure. I mean, there's like a churn pressure. I think these pumps run at 47 churn, but there's no way to really get it to work right for that type of pump in this setup. So there is a pump curve that the manufacturer has. If the jurisdiction wants to do it, what I actually will do is I'll put that on the drawing and I'll show where our demand is on that curve. I think I have an example of that coming up. So let's see, how did I get here? Flow test. I see. So basically what I'm getting at here, the flow test is related to this graph at the bottom, and you'll see the dark black line. If we go to this next slide, I have it highlighted. The reason I put in the 51 and the 50 is basically to create that line. If we don't do that, it won't put that line there. And some jurisdictions like to see that. And that's what I'm talking about. It's kind of right the way that it's in there now, but it's not really. But we'll show you that the thing works. So let's see. You'll notice the demand is well below this line. What we actually need is 26.5 GPM at 19.94 PSI. And this is where we actually look on our cut sheet for the tank, as long as those numbers, the 26.5 at 19.94 GPM, if you go under here, both of those numbers are underneath all of the top numbers on here. It's got the middle one, 30 GPM at 43 PSI, already is higher than the numbers we said. So basically it's in the middle range of this pump and it'll work great. Oh yeah, here is how I just recently did a job in another state where they don't have home hydrants there. They don't have easy access to those. And so they sent me this pump curve for the pump that they were using, what is available there. And I put this pump curve on the drawing and showed the system demand where it lies up. And it's well below the demand or the availability of the flow of these curves. One thing you'll notice too is that on the left we have, again, head pressure. So this pump is designed to work with sucking the water up 150 feet from below the ground. And the situation where we had it, it was not doing that. It was sitting next to a poly tank, just like the pictures you guys saw of the home hydrant, just like that, but with a pump on the ground next to it, sucking it right out of there. So we've got zero head. It's going to pull 38 GPM out of there all day long. 38, you'll notice, is a higher number. We were doing, I can't remember what we were calculating on that one. I think we were using extended coverage sidewalls. That's why it's such a higher GPM. All right, so one thing to note also is that the jurisdictions in the code book actually says, that the flow test should be within 12 months. I mean, that's what NFPA 13 says, that your flow test has to be no more than 12 months old. And some jurisdictions are more sticklers about that than others. And quite frankly, sometimes it's like, oh, we have one that's 18 months ago on file. Is that good, or do you need a new one? And we'll basically just try it. If the only other option is you can use this one or pay $300 to get a new one, we'll try that one first. All right, so now looking beyond that, next thing we're going to be doing is looking at our graph. We did a little bit, so we're going to be verifying our safety margin. So like I'm just highlighting there in red, that's the bar that we're normally looking at. Now, if we had put the actual, static and residual pressure from the street, it would show a similar line. We're just always trying to design so that our system is underneath that line. So now we're gonna look at K factor and flow again. We were looking at them on the cover page, but now we're gonna be looking like right here. We have the sprinklers in the row area and it shows the K factor there. But on page 2, any calc program that you're in, it'll have all, or any calc report, it'll have all of the sprinklers listed along with this information about it, including the K factor. And there we zoom in, we can see that, the 4.9. And also, this is available on your job order report and all this stuff. These are just places I'm showing you to look for all this stuff matching. Verify on our drawing, it should be shown here, 4.9. And also you'll see that there's a model number that should be matching our job order report. And we have the 13 GPM right there. So we have the correct flow for our sprinklers that we need. Just emphasizing the 13 GPM, I think. Oh yeah, here we go. So just so everybody is clear, that 13 GPM comes from this cut sheet. That's why we're using that. We're flowing 2 Senju sprinklers at 13 GPM. And so now correct pressure on our next page. We've got 5 items left. We got some blanks here. I just mentioned briefly, this is a relatively new checklist. And when we make new checklists, we always leave blanks like this because we know we're going to be adding stuff as we find good stuff to add, use it more and more. And so we just leave some space to write in some notes whenever we think of something, basically. Think I got a zoomed in one next. So yeah, okay. So the next thing, number 19, is verify correct pressure. And this is also on that page too. So this is really, it's 7 PSI is always the minimum operating pressure for sprinklers. That's really why we end up with this 13 GPM being kind of the magic number that works with this head, because that's the number that the lowest you can go and still operate the head at 7 PSI. That's why on this sprinkler, it doesn't go below 13 when you go down to the 12 by 12 and the 14 by 14. But they can achieve that on the other sprinkler. I think it was a 3 point something, because they can operate the head with lower pressure by making a smaller hole. That's what, when you're lowering the K factor, you're lowering the size of the hole that the water's coming through. All right, so the next thing on here is verify sprinklers are spaced and oriented per NFPA 13 or the manufacturer's listing. So again, we're talking about, this is the sprinkler head cut sheet. So this maximum spacing we've got here is what we designed to with the 13 GPM is 16 feet. And, that's what we designed to in our drawing as well. If you guys remember, we were doing 16 by 16 feet spacing. We have our head legend on the plan as well that says 16 by 16 in there. So verify elevation of sprinklers. I was preparing these slides kind of late today and I realized, oh, look at that. We've got a problem with our calcs. Our sprinklers are only at 4 feet off the ground. What's up with that? But this is where this is where you would be checking. And I never had this process to check through these calcs. Now I'm basically checking through them live as we're presenting this. So on this first page was just sprinklers. Now this page is all of the pipes, and it's showing you the elevation. So we only have, you notice the 0 to 1 goes from negative 1.92 to 0, and then 1 to 2 goes from 0 to 4.08, but then it never goes any higher than that. I don't know. You might not be able to see that. Here's a zoomed in version. But what those numbers represent, the 1.92 is that 1 foot 11 from the bottom of the tank to the pump. And then the 4 foot 1 is the 4.08. But we never added our 5 foot 1 elevation into our calcs. So that's something, if I was a plan reviewer, I would call them out on this. These are in error. You need to correct this. Get all of your elevation in there. So the next thing, let's see. Verify pipe length, schedule, and material against plans. So basically, we're not going to go through every single line, but I'm going to show you a line here. This is just on the left on our hydraulic calc, pipe information bar to the left. The top, it says from and to, and then we have 11 and 12. So we're representing on this line here what's going on from the node 11 to 12. So the first thing it has is they're both at the wrong elevation. They're both at only 4 feet high. They don't change in elevation, though. That's the important thing to note. The next column, we have the pipe ID. And so it's 1-inch flame guard, which is a brand of CPVC piping for fire sprinklers. And let's see, we go to the diameter is 1.101. That's correct for 1-inch CPVC, the internal diameter. And it's important because that's bigger than 1 inch. That if you just use 1 inch, you'd have a more restrictive calculation. Now the fittings, we have an elbow, and that's just because when you go from 11 to 12 and you churn down to spray your sprinkler, we've got to churn some way. All right, and then with there's the LEN. If you notice at the top, it says length, fitting, and total. So the length is 10, the fitting is 7. What that means for 7 is that one elbow is equivalent to 7 feet of 1-inch pipe. So the total is adding the actual 10 feet between the two plus 7 for that elbow. So it's adding 17 feet of pipe right there. Now it's using this C factor of 150. That's something you would want to check for. 150 is correct for CPVC. That's a smoothness coefficient for the calculations. 150 is the highest number we can use of all the pipes. It's the smoothest. If we were using steel, black steel in this situation, it would be 120. And so it has a lower C factor, so it's a lower smoothness coefficient in the formula, higher roughness value. So here we have total pressure, we have elevation, pressure loss, and then friction. So these things are all added up here on the side. It's just adding up, there's no elevation change here, which is correct, even though they are only at 4 feet. So there's no elevation loss. Our biggest pressure losses come from elevation loss in here. But basically, you'd be doing this. In the prescriptive thing, you'd be just adding up all the fittings to get these same kind of numbers off of the charts. They would be more, what is the word? Conservative than use. We can basically, like push the limits of exactly. We're using 1.101 internal diameter pipe, not just 1-inch pipe. We can basically push the limits of everything with this. with having this computer program dial it in as much as or as little as we want. How much do we want to play around with it? So, all right. So now the last thing to talk about, we check on the calcs. I want to mention now, this kind of it was going through quickly. That last step, we would do that for every single line. Now there was only 5 lines, I think, on this calc. So that's not too big a deal. But you might have 4 or 5 pages of lines that you got to sort through, and we would just look at the line, compare it to the drawing. Does this add up? Do these lengths match? Does this diameter of pipe match? Does it look like that they use the right type of pipe? Those are all the types of things we're looking at. Now, another important thing here, last thing we want to make sure we get, is the finished floor node or base of riser location. Now, this is really not very important in this project we're working on. It really comes into play, and especially in 13 systems. But we're doing a 13 style calc, and so it's asking for this information. And so this is part of why we had I don't know if you saw in the elevations where went from negative 1.92 to 0. It's because I set 1 as the finished floor to just show you what it does when you put the finished floor. That's what you put, that whatever node is your base of the riser, and then it sets that as 0. So the negative 1 foot 11 it had in the calc, it's making up to that where the 4 foot 1 starts. That's my 0 point, and going up from there. And it's a little bit above the floor, which is normal. That makes sense because basically we usually come in, and after we come through the floor, we transition in pipe type. And so we usually need the node to be right there anyway. This is a riser detail for an NFPA 13 system that we did recently. And you could see right here at a foot above the floor is where the pipe transitions. The pipe from outside is all what's called ductile iron. It's cement line ductile iron. And it comes, it's buried underground and comes up through the floor and pops out. And where we transition, just above the floor, we change pipe type. We may change pipe size radically at that point too. We always refer to that point though as the base of the riser. So that's the whole point of why we label one of the nodes finished floor node in the calcs, but it's really not necessary for this house the way we're doing it. But I just did that in the calc so we could explain that. So for this week's assignment, what we want you to do is update your plans that you're working on with the GPM and PSI from the hydraulic calculations. So this spot on your drawing, we zoom in a little bit. So it asks for a demand at the source and a demand at the base of the riser. And so again, this is actually not exactly what we put when we do a tank and pump. I'm just like wanting to expose you to more ideas than we're doing here. I'm trying to teach you about many, many things basically. And so in this one, we have a slightly altered one that just says demand at the source because the base of the riser and the source are basically the same thing at this home hydrant. But just to kind of show you this process for getting more advanced, when we get into systems where that's more important, I'm showing them as 2 different ones. So this first one, the demand at source, is straight off of our cover page. That 19.94 and 26.5 GPM you can see is directly what translates onto our drawing. It's the exact same numbers. But now for the top one, we use the same GPM, but then we use the PSI from that finished floor node. So that would be at the base of the riser. And it's, these numbers are so slightly, it's like 1 PSI different because they're so close to each other. This is not how it would really normally be. We don't worry about a finished floor node when we're doing these tanks and pumps, but I just showing you this aspect of it because it does become more important as we move into 13 systems in the future. So basically, this is what you need, guys. Update this info on your plan for your assignment. If you need to, when this video comes out on the replay, you can pause it right here. That is basically it for this week. Should be able to handle that, and should be able to get you caught up on other things if you are behind. So next week, we are going to be moving into the post-calc checklist. We finished calcs. Now there's one more checklist after the fact. Well, let me just give you a hint that since we're working on a NFPA 13D system, our post-calc checklist is directly related to whatever type of system we are working on. So it's going to be predominantly stuff related to 13D, all the stuff in the book of, dotting the I's and crossing the T's, so to speak, that they want you to have on there for a permit. But then there will be additional stuff that we just have found that is good to do. To a lot of jurisdictions like it anyway, so just process that we do to complete the job, to finish it out. Again, I want to remind everybody that this Saturday, don't forget the workshop. You want to check out SketchUp. They have a free version. It's fun and interesting to learn 3D software. It's free, so you can play around with it, web browser based. You just do it right on your web browser. Recommend playing around with it and checking out the workshop that Chris Jansen is doing again this Saturday. He's going to start designing a desk for his CAD workstation, actually. Sounds like it should be fun. All right, so we had no videos today. It was a long lecture, a lot of slides for me. So I do have actually a little video. Yes, I'm going to go into Q&A next, and I have a video prepared. It's 7 minutes, and it's from Talco Pump. It's actually 2 videos from them that I put together. One just kind of telling some info about improvements that they've been making to their pump, and one about how to set up and install your pump. And so after those are over, I will be back with the answers to your questions. So have your questions ready. And about 7 minutes.
Installing the autofill valve is the first step in installing your home hydrant. Take the lid off of the tank, feed the autofill valve down into the tank, and place the male threads through the 1-inch hole that's in the top. This is a 1-inch bulkhead fitting, which is reversed thread. So just remember that when you are installing the autofill valve, it is lefty-tighty and righty-loosey. Next, we're going to connect the incoming water supply to the autofill valve. Today, we're just using a garden hose for demonstration purposes, but NFPA 13D says that a method for refilling the tank shall be piped to the tank. Then we are going to hook the home hydrant up to our discharge once we have the tank placed. In our case here, we are using a thread by groove nipple that will go into the thread by slip orange PVC fitting. Then we are using our groove coupling to connect the home hydrant to the sprinkler system. We obviously don't have a full sprinkler system. This is just for demonstration purposes. Also, I would recommend waiting to fill the tank until you have it hooked up to the discharge in case you need to move the tank a little bit. It is really hard to move that tank once it's full of water. I've seen these hooked up lots of different ways. This is just the way that we do it in the shop. This just demonstrates how the autofill valve works. So once the tank is full, it pushes the ball up and shuts the valve and stops filling the tank. Next, we are going to hook the home hydrant up to power. Home hydrants are designed to run off of 230-volt single-phase power. They should be connected to a double-pole dedicated breaker. Always make sure that the power is off before you start wiring up the home hydrant. We drill a hole in the bottom of the control panel to feed the wires through. There are lots of methods of connecting these wires together. I'm just using wire nuts here in this video. In the field, you should be having a licensed electrician wire the home hydrant, and they have different methods for doing that. If the home hydrant has been ordered with a flow switch, now's a good time to hook that up. These are connected normally open, meaning that when the switch closes, the alarm rings. Typically, you would have some type of watertight fitting in the back of the flow switch, but for demonstration purposes today, we are just hooking it up quick and easy. Next, we're going to open the air release valve that's located below the seat of the check valve. As the water fills the volute of the pump, it pushes the air out. As soon as you get water out of the air release, the pump is primed. Now energize the panel. Flip the switch from off into auto. This will start the pump and start the timer. The pump will run at churn, which is 47 psi on this model. Now is a good time to fill your sprinkler system. We start the pump with the main discharge valve closed and then open it slowly so as to not hammer the system with 47 psi. You can put the cover back on the control panel and wait for the timer to time out after 3 minutes. The last step to the home hydrant installation is testing the home hydrant. After the timer has timed out, we're going to open the inspector's test valve, dropping the pressure, starting the pump, and testing the flow switch if it is installed.
Hey guys, my name's Jake with Talco Fire Systems, and this is the redesigned home hydrant. One thing that's always at the top of our priorities here at Talco Fire Systems is how can we make it better. The home hydrant's already pretty hard to beat as far as reliability, setup, design, installation, and footprint, but here's what we came up with. We completely redesigned our riser by adding 2 1/4-inch weldlets for the gauge and the pressure switch. This change eliminated the need for the old, bulky brass cross assembly and slimmed down our design. We also relocated the grooved coupling to the bottom of the riser instead of the middle, so that if the pump needs to be removed, the entire riser stays in place. Next, we integrated a pump volute bleeder valve and a riser drain port separated by the seat of the check valve. So bleeding the air is as easy as opening the valve. We redesigned our suction system by replacing the old CPVC suction pipe with a stainless steel flexible hose. So that if the pump ever needs to be removed, it's as easy as isolating the system, turning off power, disconnecting the suction, breaking the grooved coupling loose, and sliding the pump out. The most important part of any install is making sure it works.
All right, let's see if I can get this adjusted. How's everybody doing tonight?
Hey, Colby, how's it going?
Good, Chris. How are you doing?
Not too bad. Pretty good, man.
There's a couple of questions in the chat.
Oh, okay.
One was from Jag. He was wondering if Google Maps was the best option to find the closest hydrant, or is there a database that you use?
It's different everywhere. Like I was showing on, like, Portland has that Portland Maps .com thing that's pretty good, that has their hydrants laid out. And every jurisdiction is different, but sometimes there isn't anything, and Google Maps is all you got. So it's just kind of showing how there's you use variety of tools to get what we can. Sometimes Google Earth even can give you slightly, like, there's an actual app, Google Earth, and you can sometimes get stuff a little bit slightly different perspective with that. But yeah, just whatever we can get, databases we can get access to. It's not really any wrong way to do it. Whatever we can do. That's a good question. Thanks, Monica. Was there anything else? Probably.
Yeah, Owen had
Yeah.
a couple of questions. Oh, go ahead, Owen.
Yeah, thanks, Monica. Isn't the drop considered in the K factor? In other words, we don't have to include that in the calculations, and would that include the either the elbow or the branch C, or no?
Well, I don't know the exact answer, to be honest with you. I would have never, I would have never added that in the past, but I've had certain jurisdictions want me to do that, and so I just started doing it all the time, and I kind of forgot about why. That's a great point. Like we probably don't need it. Yeah, it's just one of those things. I just basically lots of times will even end up throwing a couple extra T's sometimes just for the heck of it, because who knows what they'll do. Especially if there's a big cushion, I'll be like, all right, well, let's really make sure that this is work good.
Go.
Yeah,
Is that what you mean, Colby? Oh, sorry. Sorry, Owen. Go ahead.
That's okay. I was just affirming what he said. I always add extra fittings, especially if there's a big cushion.
Is that what you're talking about being conservative in your explanation earlier?
Yeah,
okay.
Exactly. Yeah, that's right.
Now, Kobe, you were saying on the home hydrant, your calculations have to be just 20% below what the output is.
10%.
Okay, I thought I wrote it down.
Oh, that one that was 20%. That was the Portland report. They tell you to use 80% of static. Now
that's right. So let's just say you're at 100, and so you have to go to 80. Then you have to take off an additional 10 for the calculations.
Well, now you brought up a great point. They will allow you to forego the 10% cushion and go all the way down to 0, since they already have a 20% cushion in the static pressure. But I've been in a situation where we did it a couple times. It's not my favorite thing to do, though, because what do you do when it doesn't work? Because you have to do a flow test at the riser before you get your final inspection. And so, it kind of depends on the situation. But we have cut it down closer to 0, and it's always worked out. But you are taking a bit of a risk.
How do you do the flow test? I know we've done the bucket test, where we'll actually put some drops on the sprinkler head 1 and 2 and drop them down into a trash can, open them up, and then measure how many gallons we get in a minute. and we'll take the deflector off the head. Is that similar to what you do with the riser?
Well, they do that in some places. Like there's quite a few places in Washington State where they do it that way, but I can't really think of any in Oregon that do it that way. But like at Portland, for 13Ds, you just do it out of the drain. But for 13s, you have to add a hose valve to test out of, and you do test like with a pitot, just like you're testing the hydrant.
Well, how do you test the 13D out of the test valve? What are you looking for? Simple water flow or pressure and GPM?
Well, basically, you're checking the gauge for the PSI more than anything. I don't know. That's a good question. I don't know if City of Portland makes you collect the GPM on a house. Now that I think about it, if they do, I don't know how they do that off the top of my head. But for the bigger systems, you basically have to add a hose outlet, however many hose outlets you need, depending on the flow. And then you test those off of like a test. It's like a test header you're building at the riser. And then you test those with pitot gauges to make sure you're actually getting that much flow out of them.
So with the 13D, you're just looking for the gauge to say, to drop to the pressure that the calculations say it should be at that node point.
Yeah, because I don't see, now that I think, like, other than doing, like you said, a bucket test, I don't see how you could gauge GPM accurately with one of those gauge. It's because it's so low flow. I don't think like a hose monster or anything like that is going to register accurately. That's actually an interesting question. I'm going to have to ask somebody now next time I talk to a contractor.
So just so I'm clear, when you do the test at the site, you open the test valve and watch the gauge and make sure it doesn't go lower than what the calculations say it should be at that node point.
Yeah, for the base of the riser PSI.
Okay, I get it.
Yeah, right on. Excellent questions. We had some great people churning in their projects. Really appreciate it, guys. Everyone who's participating. Anybody out there feeling lost and still need some help? It's no problem at all. Too contact me or Monica, and we will do what we can to help you be successful.
Just locating the buttons
Right
on that CAD program, adding white background to the node so the background lines don't show. I didn't try that yet.
Gotcha. Creating a background mask is what I would call that.
By the way, there's going to be a lot of work down here in California after the fires down here.
Oh yeah, I was thinking about that. It's pretty awful. One of the guys from down there who's got a company I'm Facebook friends with. I've been following. He's got a fire pump. He's been taken around to help assisting the firefighters with because they don't have any access to water in a lot of these places.
Yeah, they're running out of water and the pressure is insane.
Yeah, so he's got, I guess it's like a testing setup or something. He's got a big fire pump and he's got a strainer that he can throw into a swimming pool because a lot of people have pools down there, and so that they've been using that for water when they run out of water.
Oh, is he the guy that has a fire engine and he goes and does the 5-year tests on sprinkler systems?
Yeah.
Okay, yeah. I've seen him or somebody similar doing the same thing with an old fire truck.
Oh, okay.
Good for him.
This is a pull behind. I know he just bought it recently for testing, and he's able to use it for this. So that's
Oh, okay.
Well, I know this is kind of a difficult night. I know it's like it's hard to keep this. It's a dry subject. I got to say, hydraulic calculations is kind of like one of the most boring parts of it, but it's also necessary to get through for this.
Did you get my submittal on the layout and calculations?
I did. I didn't get a chance to go through them, but I did, you overachiever. Good for you.
Overachiever.
You've got your
I'll make sure I'm not.
Well, you got and you had calcs as well. So I think you're the only one who already has a calc program.
But you guys, you calc from outside in, correct?
Oh yeah, that's a great. Oh yeah, let's talk about this. I forgot about that. I haven't used hydronics in such a long time. You start with the sprinklers on that one, right?
Yeah.
Instead of with Sygma, you start with the source.
Yeah, I haven't seen that done.
Yeah, that is interesting. I forgot about that. Now, does it really matter after you put the sprinklers in, what order you put the nodes in after that? I don't think it does it?
I wondered about that. I don't think so. I mean,
because I don't think Sygma, other than you have to start with the source and just after, but I don't think it matters after that what order you go in. It's just they all just have little funny things about them.
yeah, I don't know. I mean, if you have a loop system, I guess it figures it out. It balances it.
Okay, so that's an interesting, because you have like the residential version, correct?
Yes.
And you're still able to do loop systems and whatnot?
Oh, yeah.
Okay, cool. What are the limitations? Just the number of heads or?
I can do 4 heads, and that's it.
Oh, okay. Gotcha. So you could do like a 13R calc too.
Uh-huh.
Okay. Very cool.
Yeah, add all the fittings and whatever else I need to put in, and hit the calculation button.
Nice. And how long you been using that?
Oh, man. 10 years, at least.
Oh, wow.
Maybe
Okay.
15.
Really? Okay.
Yeah. Did you ever meet or talk to Sang?
Yeah, I've talked to him on the phone.
Yeah.
Yeah, he's a cool guy.
Yeah.
Well, so this makes me curious. Did you like I have an older version. I've had mine. Like I have commercial 4.4. Boy, when did I get that? That would have been. Well, I'm thinking it's about 15 years ago too. So similar to what you said.
Well, I've had an update. Now I'm at residential 6.0.
Okay. Okay, so you paid for the update. That's what I'm curious. Okay, interesting. So I never paid for the update.
And it's the only change is they added a 3 pounds for the flow switch. So you put in the FLO, and that automatically puts in 3 pounds. It was just a way to collect a little more money.
Well, and it works. So like I have the one that I have, the older version, it might have the commercial or older version, but it only works on older computers. I basically ended up to where I was going to have to pay to upgrade, or like I was using like workaround old computers to get by with this calc program for a long time. And finally it was becoming too much of a hassle. And so I upgraded to Sygma, which was, it basically was like the same price for me to purchase Sygma as it would have been to upgrade the hydronics. So I ended up going with Sygma, but the hydronics is still a good program.
Have you ever had the problem when I hit calculate, I get a error thing. It says infinite boundary, and I can't. The only way I can get around it is if I increase my domestic flow from 5 gallons to 6 gallons, or change the height of my the T for the domestic. It's really weird.
I don't remember that specific problem, but I do remember little bugs like this happening with that program. But the thing that I will say about that is that, it's just kind of like it never kept me from getting anything done. It's just kind of par for this. I mean, I started out on Haas, which is one of the older ones.
Yeah, a little.
And but it was cost a lot of money. It's a lot cheaper now, but back then it was, like thousands of dollars to buy it, and then to maintain it's a few grand every year.
Yeah.
But it was seemed like it was even more glitchy than when I got hydronics, so I kind of just put up with everything because it didn't seem that bad to me. But there was a few things here and there. I don't remember what it was, but if you did an operation in a certain order, it would not like it and glitch out or crash. But as long as you did it in a different order, it would be fine. And so I just kind of learned to work with that. I remember little things like that.
All right. Yeah, that's what I do.
There's something I can't think of. Like Sygma is pretty solid. They're really a good software team on top of that. A lot of these programs are just kind of, there's not that many people using them, and so they don't. I mean, I don't want to say anything negative about the guy you mentioned. I can't remember his name. He's a great guy, and he's a smart guy who made this program, and it works. There's a couple little glitches, but it works for a good price, and you can't complain too much. I guess it doesn't blow up my whole computer or anything.
What's the cost of Sygma? Where do you get it?
Well, okay. I'm not going to say exactly how much it is on this recording, but if you talk to me privately, I'll tell you. And the only reason is because, unfortunately, the owner of Sygma passed away last year, I believe it was. Let's see. Was it 2024? It might have been 2023 now. And I'm trying to not, like, I really love Sigma's product, and I would like to make more videos about it and whatnot, but I'm trying not to plug them too much because I don't know if the takeover of the company has successfully gone through yet after he passed. It was kind of a sudden thing that happened, that he passed away, and the programmers were trying to keep the company alive and keep it going, and it seems like they have successfully done that. But I don't know if the acquisition has completed yet, so I'm not fully plugging them out in the open until that happens to help. It basically can cause problems if they advertise too much, if it starts getting 10 times popular than it was before they acquired it or something like that. So anyway,
Okay.
basically, you just have to contact them, though. You go to their website, and there's a contact form, and you just fill it out, and they'll contact you right away. And they're great to work with. And if you mention me, they have been. We're hoping to work on getting students some sort of a discount or something like that, or I don't know, but nothing as of yet. But they're definitely friendly to us, and we're trying to keep that going. Hopefully we can get some sort of benefit to you guys. That's really who I recommend and use, mainly because of their reports, really.
Okay. I got my grandson calling me for dinner.
Awesome.
All right, I got to run.
All right, well, thanks a lot, Owen.
Thank you, everybody. It's another good class. I appreciate it. I'll keep watching the videos.
Great. Have a great night.
You too. Bye, everybody.
I want to thank everyone for coming. Hey, Chris. How are you doing?
Yeah, I was gonna say, oh, not too bad. I was just saying thanks for another good presentation.
Thanks. Sorry, I know it's probably this was a pretty dry one. But hopefully I moved through it good enough. Now, as Chris is a technician, working through the drafting side of things, just starting to learn a little bit of hydraulic calculations himself. So, any thoughts on any of this help putting it together? A clearer picture, you think, or?
Yes, yes and no. I
Didn't
do
mean to
need
put
to
you on the
like
spot.
start because yeah, no worries, man. Yeah, I just physically gotta start working on and putting in working on Sigma myself
Right, like actually practicing.
to get a better grasp of what I can do, and you know, um,
Yeah,
just uh, just using it, just get my hands on it and using it.
right. It's really basically just like data entry. You know, we're just all the whole thing is just talking about what's happening between 2 points. Basically like a spreadsheet program. Well, all right. Next week is really the wrap up. Everybody, we're going into completion. We have one more week of
I
that.
think I lost you.
Oh, we still hear you. Just saying that we are just wrapping it up, I guess, because unless anybody else has anything, next week we're going to be going into the R13D post calc checklist to wrap up the program. Dot our I's, cross our T's, and let's see what else. The final week we'll just be kind of having a review of everything and talking about where we can go from there. We're talking about other projects that we are working on, those types of things. And so, yeah, look forward to everybody's success with their projects and seeing what you can do. If anybody does need any assistance, please reach out to us so we can help you. We want to see you succeed. I think, unless anybody else has anything, we'll call it a night, Monica. Have a good night, everybody.
Good night, guys. Good night, guys.